Okay, hello everyone. Happy Friday. Hope you guys are all still doing well. We are at the end of our log functions unit. Normally we'll have a test, but since we're not in the classroom right now, we're just going to do a unit review, and then we'll see what happens after spring break. Okay, so all of these we have seen already. We're doing a unit review. So I'll just kind of go over a few questions with you guys to kind of refresh you a little bit, and then I'll let you guys get to work on the rest of these. So first of all, finding inverse of functions algebraically. So let me go ahead and do the one on the right. So again, we always have two steps. First step is to switch x and y. Okay, and then the second step is to solve for y. So here's y. Let's first go ahead and add 3 to both sides. X plus 3 is equal to log of y minus 9. Okay, now at this point, we want to rewrite this in exponential form. And again, remember, if there's no base, it's implied to be base 10. So let's go ahead and use our circle method. So we have 10 to the x plus 3 is equal to y minus 9. And then, of course, one more step, add 9 to both sides. So I get y is equal to 10 to the x plus 3, and then plus 9. And then remember to put it in function notation. So I get g inverse of x is equal to 10 to the x plus 3 plus 9. Okay, and then let's go ahead and do a couple of evaluating log expressions. So let me try this one right down here, log base 1/16 of 64. And remember, if you're ever not sure, you can always first rewrite it in the other form. So I get 1/16 to the power of x equals 64. And now you want to change them to the same base. So 1/16 is 1 over 4 squared is x. Here we can use base 4. So then I get 4 to the negative 2 to the x is 4 cubed. And then I can set up an equation like so, divided by negative 2. So I get x is negative 3 over 2. There it is. And then let me go ahead and do the one down here where we're going to have to use the properties of logs. So first of all, remember, if you have these exponents, you can actually move them. If you have these coefficients, you can actually move them as exponents. So I can have log of 2 squared plus log of 5 squared plus log of 10. Log of 2 squared is 4. 5 squared is 25. And then plus log of 10. And then product rule tells us that we can actually multiply all of these together. So I can do 4 times 25 times 10, which is log of, it looks like 1,000. Okay, and again, since there's no base that's written, we know it's going to be implied as base 10. And then what's log base 10 of 1,000? Or you can think of it as 10 to the what power is 1,000, and that's your third power. Okay, let's go ahead and do, keep going. Let's go ahead and try one of these graphs. And then I'll do the second one. So again, let's first remember our key points. We're going to use these as our y values, negative 1, 0, 1, and 2. And in this case, our parent function is log base 3 of x. So then let's go ahead and find what the x values are. So when y is negative 1, 3 to the negative 1 is 1/3, or 0.33. When y is 0, 3 to the 0 is 1. And similarly for the rest of these. And then we have, let's put in our transformations. So here I'm shifting to the left by 5. So I get negative 4, I get negative 2, I get 4. And here I get a fraction. And then for the y values, I'm first going to multiply by negative 2. So I should end up with these. And then let's go down 1, 1, negative 3, negative 5. And then remember, as we've done all year, we're going to graph the outside columns. And then before I do that, let's first figure out where my asymptote is. Well, this graph is shifted to the left 5. So then our vertical asymptote, instead of x equals 0, it's going to be at x equals negative 5. Let me also write that down over here, x equals negative 5. And let's go ahead and graph our points. So I'll start with negative 4, negative 1, negative 2, 1, 2, 3, and then 4, comma, negative 5, 1, 2, 3, 4, 5. And then the last one is going to be about somewhere over here. And then now we can go ahead and connect our points. Okay, something like that should be good. And then I'll let you guys fill in the rest of these key features. This is log base 3 of x. Okay, and then let's go ahead and try a couple of solving ones as well. Let's go ahead and do maybe one right over here. Okay, so if I have all this going on, remember I want to solve for isolate my log. So let's go ahead and add 9 to both sides first. Y plus 2 equals negative 2. And then let's go ahead and divide by negative 2. So I'll get log base 7 of y plus 2 equals 1. Okay, and once again, once we're here, let's go ahead and rewrite this in exponential form. So I get 7 to the first power equals y plus 2. 7 to the first power is just 7. So let's go ahead and we can subtract 2 on both sides and we get y equals 5. But of course, you should make sure we always check your answers. So we have y is 5. So let's plug that in. Minus 9 equals negative 11. And then we see that this is going to be log base 7 of 7, which is a positive number. So we know that's going to be checked out. So y equals 5 will be a valid solution. And then let's go ahead and try maybe this one right over here. So here we have this on the left-hand side. So we can first use the properties of logs. We can use quotient rule. And since we're subtracting these with the same base, we can make it division. And then again, once you're here, we can go ahead and change it to the other form. So I'll have 10a minus 3 over a is equal to 9. Multiply both sides by a. I get 10a minus 3 is equal to 9a. And then let's go ahead and subtract 10a on both sides. And I'll get negative 3 equals negative a. Divided by negative 1, it looks like a equals 3. Once again, make sure you double check your work. So I'll have log base 9 of 10 times 3 minus 3 minus log base 9 of 3 equals 1. And then we see that both of these will be positive. So in this case, this will work as well. So there's my solution, a equals 3. All right, and then let's go to the last page. I will we'll go ahead and kind of work through one of these as well. This one's going to be a bit more complicated, but we can still use the same technique. So here we can use product rule because they're being added. So let's go ahead and do that. Log base 9 of 9. Okay, and let's actually go ahead and simplify the inside a little bit. So remember, if we're multiplying these, remember to distribute. So I should have x squared minus 5x plus 3x minus 15 is equal to log base 9 of 9. And then let's simplify the inside. X squared minus 2x minus 15 equals log base 9 of 9. And now, because we have the same base, log base 9 on both sides, we can just set those equal to each other. Minus 15 equals 9. And this becomes a quadratic, which we know how to solve by factoring. That's minus 24 equals 0. So I want two numbers that add up to -2 multiplied by negative 24. It looks like it'll be -6 and 4. And then solve for x. So I get 6 and -4. And then make sure you double check your work. I'm running out of room here, but I'll try to make it work. So let's first check 6. X equals 6. And if we notice, if we plug it in, we get 6 plus 3 plus log base 9 of 6 minus 5 equals log base 9 of 9. In this case, both of these are positive. So 6 is going to work. But let's also check -4. And then if we kind of just look at it really quickly, we see that this one will not, because we will end up doing taking a log of a negative number. So -4 minus 5 here is equal to log base 9 of 9. We get -1 here, and we also get a negative here. So -4 is going to be no good. And we call that extraneous solution. There it is. Okay, and then lastly, we just have a couple of word problems. I guess we can set one up together. So let's look at this one with compound interest. So remember, the general formula for compound interest is this. And then PE to the RT if it's continuous. In this case, this is not continuous. So we're putting in 2,500 in the bank. It's 3.1% interest. Put that as a decimal. Compounded monthly. So in this case, N is 12 to the 12t. How long will it take for the money to grow to 4,000? So 4,000 will go here on the left because that's what we want to end up with. And here the goal is to solve for t. And again, this is pretty similar to the ones we did above with solving equations. So we can first kind of simplify the inside a little bit. We might need to do a little rounding. So here I get 1.0026 to the power of 12t. And then let's go ahead and divide by 2,500 on both sides. And we get 1.6 is equal to 1.0026 to the 12t. And now we can go ahead and change this into log form. So I have log of 1.0026 of 1.6 equals 12t. And then this on the left, you can just use your calculator and then go ahead and divide by 12. And that will be your final answer. So I'll let you guys finish up that part. And okay, so that is the unit pretty much. We are now done with the log functions unit. So please go ahead and take a look at the rest of these and submit your work. It is going to be spring break for you guys, so I hope you guys stay safe, and please do stay safe. We don't know what's going to happen over the next couple of weeks. So we'll see if we're going to be back in school once spring break ends. But as always, please let me know if you have any questions. And I hope you guys have a great rest of your day.